Unit 1 Review Scientific Inquiry. As you might remember, the main objectives of this unit were to use science to explain natural phenomena while recognizing limitations and implications on society, to develop hypotheses and test those proposed explanations using thoughtful techniques and procedures, and also to interpret and analyze data to develop additional hypotheses, question methods, and develop conclusions. So when we look at developing hypotheses, here are some things we should remember. You should look for patterns, making observations in anything that you're recording, and then essentially a hypothesis is just a prediction or an answer to your scientific problem. Generally, we write hypotheses in an if-then because statement, but you can also write it just as a statement. So for example, if students eat breakfast, then they will perform better in school because nutrients are important for brain development. However, you could also just say students will do better in school after having breakfast. That's also a prediction. Just make sure, number one, do not write your hypothesis as a question. So the scientific design process, where do we start? Well, we have to identify the problem, and we write that in the form of a question. That's the only thing that can be written in the form of a question. Then we go to the hypothesis, which we just talked about, to predict the answer to that problem. Then we collect the data to prove or disprove the hypothesis. When we do our data collection, it's important that we identify our variables and controls. Remember that the independent variable is the only variable that you change in the experiment. The dependent variable is what you measure as a result, and the controls are everything that stays the same, so everything else. So for the example I just gave about the breakfast, eating breakfast and doing well in school, whether or not a person ate breakfast would be our independent variable, and the dependent variable, what we measure, would be the grades that students get. Controls would be maybe the age of the students, the school they go to, the hours that they go to school, other factors like that. Number 4, data analysis. So now we would control the groups and variables. So in the case of the example, the control group maybe wouldn't eat breakfast, and the experimental group would eat breakfast. And then we would compare how those two groups would do at the end of the experiment and which group had higher grades. The conclusion is to either support or reject the hypothesis, so always remember back what your hypothesis was in order to determine a conclusion. If it's rejected, you just start over and create a new hypothesis with your new information. Making experiments more valid. Often in your regions, you'll see questions about validity. So make sure that we're only changing one variable at a time. Obviously, we can't change 10 different things and then expect to draw conclusions because we don't know what caused what changes. We also want to experiment with a large sample size. So whether we're testing people, animals, plants, anything, we need to have more than just a couple people, right? Generally speaking, we're talking about 100 or even 1,000 different organisms. But it really just depends on the nature of the experiment. And lastly, we want to make sure that we repeat with multiple trials to check that what we actually thought was true is actually true. So here's an example of the scientific design. So the question is, does coconut oil make your hair grow faster? The hypothesis, or an example of a hypothesis, could be if you use coconut oil, then your hair will grow faster. We could also add a because coconut oil has fats in it that help hair growth. The independent variable is whether we use coconut oil on the hair. The dependent variable, again, what we're measuring is hair growth. The controls are going to be the hairbrush, the time in the shower, diet. Control group will be 50 people who don't use coconut oil, and then the experimental is 50 people who do use coconut oil. And the data, if we were explaining data that supported a hypothesis, the experimental group had 5 inches of hair growth in 4 weeks, while the control group only had 3 inches of hair growth. So that shows the difference in the two groups, and it also supports the hypothesis that if you're using the coconut oil, which the experimental group had, then you would have faster hair growth. So let's try another one. The new question is, will crickets chirp more if the temperature is warmer? And a cricket is just an insect that makes a little noise, okay? And we call it a chirp. So take a moment now and try to write out your hypothesis, your independent and dependent variable, your controls, your control group, experimental group, and what data would support your hypothesis. At this time, you can pause the video and then come back to check your answers. Okay, so it looks like you've already taken the time to do this. So what we're going to do is go through the answer. The hypothesis should be something like, if the temperature is warmer, the crickets will chirp more. The independent variable is temperature. Dependent variable is the number of times crickets chirp per minute, or something like the number of times that crickets are chirping. Controls would be things like the type of crickets, the soil, the time of day. Control group is the 100 crickets in the cold temperature, right? Because we're testing if it's warmer. So the crickets in warm temperature is our experimental group. And then the data that would prove our hypothesis to be correct would be that the crickets in the warm temperature, or the experimental group, chirped 30 times more per minute than the crickets in cold temperature. Okay, so lastly, don't forget to write out your 2 questions that you could ask yourself to check your understanding of this video.